us the tools that are available that we can each install personally, because now we don't have that perimeter security anymore. We're not working inside our offices.
You're kind of cutting off.
Yeah, we barely hear you. Can you post it on the chat?
Okay, I'll post in chat.
Thank you.
I think what was said was, can we have a session talking about tools for people working at home? I think that's what you said, right?
Oh, oh, that would be good. We can, yeah, we can. I heard somebody talking about that. Let me do some. I'll reach out to. I mean, you guys. I hope all of you are in the channel. Actually, let me share this now. So before we start the meeting, and then I'll let Phil take the take the floor. We do have, if we do have a Slack, which is person-27 .slack.com. And we do have, if you want to bring that up, I'm sure there's tons of people. We have people that work actually at small companies like Soho, for example. We have people that work at Cisco. We have people from all over the world, all kinds of enterprises. So I'm sure we can put something together and help you guys out. So yeah, I'm going to research on that. Our next meeting will be container security on the 23rd, and then there is the drone. I will be doing the drone presentation. Hopefully I will have a couple of demos for you, an actual exploitation, working on some of it. For today, we're going to have the Pwnagotchi with Phil, which is a our Wi-Fi wizard at Pacific Hackers. Has been with us for quite a bit and spoken at the Pacific Hackers Conference. Last week, we have an awesome CTF with Sambone. It was pretty awesome. I'd never seen Cobol, and that was very, very, very educational. Just a quick update. The meetings will continue online until it's safe to go back. I'm starting to think this is starting to look like July, August, or even September. But it seems like we're moving. I don't know where yet as far as the pandemic, but we're certainly starting to look at reopening. Florida, which is where I am right now, is definitely ahead of everybody because they never really care. And by chance, they done pretty good, in all honesty. Not DEFCON, that was an announcement done yesterday. There will be some apparently some virtual events. And Black Hat, I think, is going virtual as well. But unfortunately, there's no there. It's, I guess this is one of our huge losses of this year. We're not going to be able to go to Vegas, and that sucks. So just like you, we're all mourning DEFCON. So we'll figure out a way to happen. I can tell you, I am part of. Now I can disclose this. I am part of the Red Team Village. There will be a Red Team Village summit next week, May 16. I will be speaking there, and there's likely to be a Red Team Village virtual during the time of DEFCON. They haven't announced it yet, but I think that's the purpose. And just like them, there will be many others. I'm sure everybody's trying to figure out how to do this, either with virtual reality or a mix of 2D, 3D. That's what I've been hearing. So talking about that, Person 27 has a team in hackasat.com. We already registered. We have some good people that have been actually satellite operators, the U.S. Mill, and they have some sort of the experience and knowledge on satellites. Obviously, I welcome everybody that wants to join. But again, if you want to be in touch, you have to join the Slack. So if you want to join the Slack, you can send me an email at info@phack.org, and I will add you as quickly as that. And we have plenty of channels. You can talk to them, and hopefully we'll participate and have fun. We're out of Keybase for obvious reasons. Keybase was our backup channel, and we actually even had some code in it. But due to the recent news, we decided to get out of Keybase. We will not be using Keybase anymore. So if you were ever part of the Keybase public space for Percent 27, this is gone. The job offers, it looks like, unfortunately, the layoffs have increased, and it's getting there, right? Everybody has been affected. Some of us have already been caught in compensation. Some others have been let go. If that's the case for you, I have to tell you, there is a channel called Job Offers. And Job Offers, I'm posting everything I'm getting, and most of them are remote. And some of them, actually, we've been able to get some track on some people to get them placed. So there are jobs, which is the important thing. There are layoffs, but there are also jobs. So I'm sure that, you know, if the economy keeps going down, this is going to get worse. But as of now, I have to tell you, there are quite a bit of jobs. So if you check on the Job Offers channel, I'm sure you can find something, and you can talk to us. And there are companies that, you know, they hire by word of mouth, and if any of us, people we know that are part of the other group, will reach out to them, you get an opportunity to be interviewed. We'll continue reviewing the situation. The situation is, of course, completely unclear. We don't know what's going to happen, but we'll continue reviewing it. These meetings will be posted, and I always get that question, YouTube. The thing is that because we don't have 100 people in YouTube, we can't have our own URL. So once we have 100 subscriptions or something, we will be able to have our own. We'll be able to have our own channel name or customized name, and so keep track of it. I will be posting this. I'll be actually using a new tool that's called Restream.io. Basically, I will record the recording of this meeting will probably be broadcasted afterwards. And then again, keep in touch with us. That's where the ideas, the meetings, the collaboration, the training, lots of people that are trying to get training materials or books. We have that, and you can get it for free. We're not going to charge you for anything. We're trying to help everybody, any level, anywhere you come from. It's an open channel, and we want to make sure that all of you can support you as much as we can, because I know things are getting tough out there. So if you join this Slack, we'll be glad to talk to you and help you wherever we can. So with that, today we're going to have our very own Phil Morgan, and Phil's going to talk about Pwnagotchi. Pwnagotchi is a tool that I've been hearing about since I believe earlier this year or late last year, I believe. And it has to do a lot with Wi-Fi and deep learning. And he's going to go over the entire thing, how to build it, how you use it. So Phil, with that in mind, I'm going to give you the floor.
Oh,
Thank you, sir.
quick question, Phil. Do you want us to interrupt you for questions, or are you going to read them from the chat? How do you want to do it?
Well, because it's being recorded, I'd like it to flow. Maybe we can stop 20 minutes, every 20 minutes, and ask for questions. What do you guys want me to do?
No, it's you're the presenter, so however you want to do it, that's fine. So every 20 minutes, we can go back to the chat and ask the questions.
Yeah, okay. So if you see chats coming in, well, actually, maybe I'll get started, and at convenient section endings, we can open up for questions.
Sounds good.
I'm happy to keep this really fluid. I just want to make sure everybody enjoys it. Oh, and by the way, guys, just to let you know, there's a user called OB1 in. That's just my iPad, all right? Just so I can get feedback on what I'm presenting. So if you wonder who the heck's OB1, that's who. All right, let's do this. So hello, everyone, and welcome. I hope everyone's staying safe and having fun. Here we go. This is our Pwnagotchi presentation. Obviously, a little disclaimer, right? You know, please don't go and build a Pwnagotchi and then see if you know, let's see what happens at the airport. No, don't do that, please. So obviously, the information we give you, we expect you all to be quite sane with. This is the company I work for. A little bit about this. if you're really interested, go back and watch the video. I'm not going to spend too much time on this. A little bit about me. I've been doing wireless for a long time, and I've now got into security and wireless. I'm now getting into IoT and all sorts of things, and I'm loving it. I'm having great fun with it. Here's my details. If anybody does want to reach out to me, or my boss let me develop this slide set and let me use it, and obviously she needs to have a little, you know, hey, here's the sales number for NC Expert. She wants some free marketing out of it. So now I've done my obligation, and I can justify me being in the office doing all this work in my office time. All right. So this is what we're going to be doing. We're going to talk about the Pwnagotchi. The Pwnagotchi is a great little device. Okay. So we're going to talk about it, how you get one, how it behaves. We'll cover some Wi-Fi theory about what the Pwnagotchi does. We'll talk about the display, and my wife actually uttered the words, "Oh, it's crying," at one point. I was like, okay, because it was crying because its friend had gone away or something, and it's just really cute. Then the modes, basic configuration, how we connect to it, and how we get the data off the Pwnagotchi. All right. So the Pwnagotchi, let's talk about it. There's one. It's basically a Raspberry Pi Zero wireless. I got a little extender on it so I can move the screen off, and I'm actually showing you a little USB case that I got for it that makes it quite simply to plug into a USB device. All this we'll talk about later. So effectively, it's a Raspberry Pi Zero W with a little LCD screen on. Okay. Now, the Pwnagotchi comes from the concept of the Tamagotchi. It's that old game from the 90s. Remember, you had to keep it alive. Parents bought them for their children, then had to get up in the middle of the night because they didn't want the thing to die. Parents ended up looking after these things. It's the 2020 now, right? And we bang smack in a COVID virus. The apocalypse is upon us. I know how the Tamagotchi felt. I'm trying to keep myself alive and entertained at the moment. But apparently, for those who are excited, the Tamagotchi is back. It's now come back in super duper new colors and things, so you can get them again in 2020, and you can spend all these hours you've suddenly gained because you're stuck at home keeping the Tamagotchi alive. So you had to feed it, you had to exercise it, you had to play with it. So what the Pwnagotchi does, it feeds on WPA, WPA2 SSID handshakes. Okay, so what it wants you to do, it'll tell you, I'm bored, and then take it for a walk, and let it ingest some new handshakes. It will also try and associate to an AP to try and get PMK IDs. And watch out for this. Not only does it sniff and store the information as PCAPs, it will also de-authenticate. Now, warning, right? There may be legal consequences of having it do a deal. If you get a Pwnagotchi and you turn it on and you're working from home and your Wi-Fi's misbehaving, just remember the Pwnagotchi is going to be de-authenticating to learn 4 handshakes. It will try and associate to the SSID and learn a PMK ID as well. And a separate subject that I'm not going to go anywhere near today, the AI of the Pwnagotchi, it is self-learning, and it makes itself better at doing its thing. It is tied to an interface. You've got to be careful. Don't train it on 2.4 gig and then suddenly open up a 5 gig interface. It doesn't work that way. It learns how to become better at being a Pwnagotchi. Okay, and there's a very simple algorithm, and I've got to give credit to the guys that do this here. Where are we? You've got to go to this website where everything you need to know about the Pwnagotchi is on this website. And I've got to give a call out to the guys. They've done, the guys and gals, they've done a great job on this website. Okay, the algorithm for those interested is explained on this website. It's very simple. I think it's like, effectively, it's a small number of lines of code, but it's a self-learning. All right, so a quick mention. Doing de-authentications may have legal consequences. Doing de-authentications may have legal consequences. Doing de-authentications may have legal consequences. What am I talking about? I was taught by a preacher in Wales, where I come from, over in the United Kingdom, and he told me, whenever you're speaking, if it's important, say it 3 times. The first time you say something, only those paying attention get it. Second time you say it, most people get it. The third time, everybody should get it. And it's very important. You may not want to have your Pwnagotchi and take it into work, the DMV, the police station, the government building, the military base, or the airport. All right? You can turn off the de-authentication, so it just simply learns captures. The 4-way handshake captures over the air. Now, gray area, you're broadcasting this capture. If someone captures it, apologies, you're broadcasting the 4-way handshake. If someone captures it, have they actually stolen anything? Or is it your fault for broadcasting it? So that's like a gray area. But if you take this into like an airport or near a police station or something, and you start doing de-authentications, that's a different situation, right? So be aware when you're walking around with your Pwnagotchi in your bag, plugged into a battery, if it's doing de-authentications, technically it's attacking. And that could have legal consequences. All right. So the Pwnagotchi, it learns, it's based on Betacap. And all you need to kick off and start off with this is a Raspberry Pi Zero wireless. All right. So you need to get one. So what do you need? You need a Raspberry Pi Zero wireless. You can buy Raspberry Pi Zeros very, very cheap. If you buy one, the easy option is to buy one with the header installed. Okay. If you're not good at soldering, you can buy one of these. Now, when I first bought one 2 or 3 months ago, they were like maybe $10. Then they went up to $15, $25, and I think the last one I saw was they wanted $35 because somebody's realized there's a lot of people out there that want to build Pwnagotchis. So they are taking these headers, putting the headers on, soldering them, then selling them at an exorbitant rate and making some money. Again, $35 is a lot easier than trying to solder a header onto a Raspberry Pi Zero if you've never done soldering ever before. Now, if you're experienced with soldering, you know what? Maybe you should learn the soldering technique with some videos off YouTube, right? We've got time. But getting it with the header pre-installed makes life easy. You need some software on the next slide. Then you need a screen. And so here, for example, oops, excuse me. Here, for example, we see a little LCD screen. Now, apologies for the screen jump, and I'm using my Apple mouse, and sometimes when I touch it, it interprets that as, oh, Phil wants me to go back 2 screens. I need to turn that feature off. But anyway, not to worry about that. The Waveshare V2 works well for the screen. You need an SD card. I think I use 32 gig. Just gives a little bit more space. You want a power bank and a cable and a disk imager. I use Etcher. I'm on a Mac. I use Etcher. Makes life simple for me. Up until now, I've been using version 1.43 of the Pwnagotchi image. They just dropped version 1.5 about 2 weeks ago or so. Full disclosure, honestly, I haven't got it working yet. I didn't want to get it working and spend time playing with it for this talk. So 1.43 works. I've got it working very well. It does everything I need it to. So this talk is based on 1.43. I don't know why I dropped 1.53 on an SD card, plugged it into the Raspberry Pi, and nothing happened. So I need to do some research. I haven't had time to get around to it. If anybody knows the solution, please shout out now. But 1.43 is what I'm using for this talk. 1.53 is the latest one out. It does some bug fixes. It does some fine tunes. It does some optimizations and things. One of the most important things it does is the config file you put on the SD card initially to tune your Pwnagotchi has moved from a YAML file to a TOML file, which stands for Tom's Obvious Minimal Language. And as I mentioned, I haven't spent any time with it at all. I put an SD card in, it didn't boot. I went back to 1.43 and continued developing this webinar. So my job probably tomorrow and moving on is to try and get 153 working. So you really need to get a case. So a case, of course, in quotes. Here's an example of a Raspberry Pi case, nice and simple. Okay. You really want something to protect the underside because you don't want to put the Raspberry Pi down and have any of the pins short out or anything if you put it on some kind of metal surface or something. So the plastic case really protects the underside of the Raspberry Pi. You may want to get an optional larger screen. Now, obviously, I blanked out this because here I installed the 2.7-inch paper hat. It's an ink display, so when it displays something, it doesn't change until you rewrite something to the screen. It had a cuss word on there, minor cuss word, but I didn't want this video being marked as adult on YouTube because there's a swear word in there. So just be aware this is not a toy. The Pwnagotchi is not a kid's toy. It's an adult's toy, right? It's for us to play with. So there does occasionally have a cuss word in the display to be aware before you let your 8-year-old play with it or something. One thing I found, I got the 2.7-inch working after a little bit of work, and I didn't like it. The smaller display works really well. The 2.7 has an issue where before it writes to the screen, it clears the screen. So you see this flashing effect, which I didn't like. The bigger screen, I actually did it on my Raspberry Pi 4. It just looked cooler. But I didn't like it. I actually preferred the smaller screen, and I stuck with the smaller screen. The Raspberry Pi Zero does not have a hardware clock. So you may want to add a hardware clock to that. How to do this is all on the Pwnagotchi.ai. You do need to dig out your soldering iron and do some cut and pasting with solder, as it were. Or put up with the errors. You may see errors, log, date, time, and time synchronization. Because the Raspberry Pi Zero doesn't have a hardware clock, when you turn it off, you may get some clock drift. Just be aware of that. Here's a cool little case I got. Kudos to these guys. Basically, it's a little dongle that you put the Raspberry Pi on. I bought a little header extender so I can get the screen away from the Raspberry Pi. If you're going to put the heat sinks on the chips, you need to extend the screen. Here's a very excessive one because I used up all my smaller ones on other things. So I just plugged this in just to show everybody. And then you've got this little device that plugs into the USB. It powers from the USB. So you can have a battery pack. I've actually got an external USB hub here, and I got it plugged in the end. But it gives you this little cool little blue color. Just makes it pretty. And I like this. And I got one of my, I got 4 of these, 2 Pi Zeros, 1 Raspberry Pi 3B Plus, and 1 Raspberry Pi 4. And I've also got another one that I give to my son who's here with me. He likes to play along with these. He's my apprentice, right, Howard? my Padawan. He's getting into IT, networking, cyber, and so on and so forth. So he's got one as well. But I like this little interface because it does just let you slide the USB in. Other options, the Raspberry Pi Zero is 2.4 gigahertz only. So if you do want to start looking at stuff on the 5 gigahertz, you need to look at the Raspberry Pi 3 or the 3B, or you do need to look at the Raspberry Pi 4. Now, heads up, these do need more power, okay? If you find that your Raspberry Pi keeps rebooting, it's because you're not giving it enough power. So I've got it working off a power bank, but you need like 2.5 amps or so to get the Raspberry Pi 3 and the 4 working. The Raspberry Pi 4, it's got this, it's a good idea if you're using a Raspberry Pi 4 to have a fan on it to cool down the components. It does run a little hotter. What happens is, as the Pwnagotchi enables the 2.4 gigahertz and the 5 gigahertz, and it may also get better cap to start playing with the Bluetooth and things. As it does this, it needs more power, it runs out of power, and the only choice it's got is to reboot. Okay, so look in here, you can see this one has been running for 47 minutes. I actually had this one, the Raspberry Pi 3B Plus, I had it working for 40 hours on a particular power bank. Okay. So here's what I'm using, just to let you know, as my power. I bought this one. It's a Jav. It's got two standard USBs, I say standard, old USBs, and two of the new USB-Cs. I plugged this into the Raspberry Pi 4 is USB-C, and I have not successfully got my Raspberry Pi 4 to keep on running without rebooting yet. I haven't had this power supply for long, and it's got a high power USB-C. I just plugged it in yesterday to the high powered one to see if that provides enough. This little guy here, I bought the iSmart Rav Power. The middle option here gives 2.5 amps, and this happily fed my Raspberry Pi 3B Plus, and it went for 40 hours or so in my testing. This little guy down here, this is one that I bought because it gives more power. And actually, I apologize, I'm wrong. It wasn't this guy that I plugged it in, it was this little guy down here. Now, this is a Rav Power with a USB-C to charge and an older USB as output. It works, this is the one, I'm sorry, I'm wrong. This one here is what I use for my Raspberry Pi Zeros. The middle output is supposed to be 2.4 amps, and it wouldn't keep the Raspberry Pi 3B going. This one did keep the Raspberry Pi 3B going, but the problem I had with it was this top one here. You can see this is the in charge, and this is the out. There's 3 USB slots here, and it tells you how much current they're taking, which I can't seem to find in the newer devices. This is an older device. When I plug in this charger, it has the ability to allow power out and allow power in at the same time. So if I come into work, I plug this in, and my Raspberry Pi Zero keeps on running. Now this guy, while it successfully did keep the Raspberry Pi 3B running, whenever I unplugged the power, the USB power, my Raspberry Pi rebooted. My Raspberry Pi went off, and then when I turned the power on, the Raspberry Pi rebooted. So this device does not seem to allow fluid power in and out and stopping of power without resetting the device. Whereas this older one, not a problem at all. So just be aware there's lots of pros and cons of which devices you use. But this Rav Power one here, I did successfully run the Raspberry Pi 3B for a long time, which means it's giving it enough power. Now, it may be a key sequence or a button sequence I've got to press, and I haven't had time to experiment with that. So I just know that it does not constantly provide power when you even if you unplug this guy. If I unplug this guy and he's connected in here, my Raspberry Pi would reboot. All right. Oh yeah, you need hashcat. Just one thing to be aware of. All right. Optional extras. When you run hashcat, if you haven't loaded the right drivers, it won't work on the CPU. You've got to have compatible drivers for hashcat to work on a CPU. So you may be like, hey dude, I've got one of these new AMD machines. Yeah, but have you got the right drivers installed? So what I did was I got it working with a graphics card. This is my proof of concept machine, and this is my final build. It's actually an Ethereum miner that I experimented with. My wife let me buy and build this. Cost about $2,500 all in. These are not very powerful graphic cards. It was a proof of concept thing, really. These are 1050 Ti's, and this is a 1070 Ti at the end. Actually, it may not be a Ti, actually. It may just be a straight 1070. But this guy here is about 2 or 3 times the power of the other 1050 Ti's. She let me build it because she's like, hey, it's cheaper than golf, right? Okay. You know, you have lots of people play golf and the spouses are like, you know, it costs a lot. My wife was, yep, I'm happy to build that because it's cheaper than golf. I built this for Ethereum. It no longer mines Ethereum because the Ethereum's moved on now. The Ethereum data is too big to install on these. It shouldn't be. These are all 4 gigs. They should work. They don't. I use NiceHash every now and again to play around with it. But now this has become my hashcat machine. And it's Windows. I try and keep things simple. Eventually, I might convert over to doing things with like Linux and things. But I installed Windows. I installed the miner on Windows. I installed hashcat on Windows. And it's really easy to do. I did experiment with doing it on Linux. And the Linux booted and complained bitterly that I had 8 graphics cards. So I took a screenshot, added it to my to-do list, get Linux working on the 8 graphics cards, and it's still on my to-do list, okay? Because Windows just works. It was that easy. But you do get more performance if you get Linux working, and of course we all shouldn't be afraid of getting Linux working on these machines, but there's lots of jiggery pokery and dark magic you have to do to get Linux to understand that there's a graphics card inbuilt on the motherboard that connects to the screen, but we are using these other graphics cards as compute engines, and we don't want Linux to try and initialize every single one of them. And that's what I haven't got working yet. I'm sure some of you are writing the code in the chat as we speak. Thank you very much. All right, so behavior. So your Pwnagotchi will make friends. Now, my Pwnagotchi is named after my family members. My dad really was called Merlin. My mom is Joyce. My dad's no longer with us, unfortunately. He passed on. So effectively, I can tell people that I am a descendant of Merlin, of course, who was the famous Celtic wizard in King Arthur's time. And that really was my dad's name. And so, yeah, so I called my little 2 Raspberry Pis, the zeros are called Merlin and Joyce, after my parents, who I do have a lot of respect and love for. And so what happens, here you can see Joyce is very happy because she's found Merlin, another Pwnagotchi is nearby, and also she's found Myra. So Myra and Muriel are my 2 aunts who I was very close to growing up as well. So I thought, hey, what shall I call my Pwnagotchis? I know, let's immortalize my family. All right, so some Wi-Fi theory you may or may not be aware of. So when we connect to a wireless network, we start off in a state machine of unauthenticated and associated. We then authenticate to the access point, which contains and uses absolutely no security whatsoever. Can I come in? Yes. Can I come in? Yes. We've done away with actual authentication when we got rid of shared security with web. So the open authentication really is, can I come in? Yes. Once you're authenticated, then you associate. Now, association is a big deal. You can only be associated to one AP at a time. When you associate, you get an association ID. So here, for example, we've got association ID number 7. Now, there are technically 3 things you can do once you're associated. Okay? This depends on how you've configured your AP. You can do what most people do in the small office, home office environment. You can create WPA2 personal, which means you have a pre-shared key. So you put a passphrase on the client and you put a passphrase on the AP. Okay? Perfectly safe to do as long as you follow some very basic rules. Rule number 1, you change the pre-shared key occasionally, maybe every month. Second thing, if someone leaves the company, you change the pre-shared key. Now, I can't even keep a straight face doing this, and I know that doesn't happen. Right? I know there are companies that just keep the same pre-shared key, and we'll talk a little bit more of that in the next slide of why you shouldn't do that. You should never use pre-shared key if you're in a security environment. Okay? Well, Phil, what if I use a pre-shared key with a 25-character passphrase? Well, what you'll do is you'll write it down somewhere. And then that defeats the security, because then all the hacker has to do, or the cracker, I should say, all the bad guy has to do, the bad guy, the bad gal, the black hat, all they have to do is find where you've written it down. Okay? So as you make the personal key more complex, your users will start writing it down on a yellow sticky and maybe stick it under the keyboard. I worked in a company recently. The passphrase for the pre-shared key was on a yellow sticky stuck to the monitor. Ouch. All right. The ultimate, of course, in serious security for Wi-Fi is using WPA2 Enterprise with 802.1x EAP and radius. Now, the other thing you may come across is I call this secondary security. This is where security really takes place. Secondary security, like you have in the coffee shop, like you have at the airport, like you have on the bus or whatever, on the train, on the cruise ship. They want you to use Wi-Fi, so they don't use WPA2 Enterprise at all. Now, you never leave this wide open, ever, okay? What you do is you will use some kind of web authentication, also known as hotspot or captive portal, where, first of all, you filter what is allowed on the free network. So you only allow maybe HTTP, HTTPS, VPN traffic, email, POP3 IMAP, MAPI, that sort of stuff. You should allow that through. Everything else is blocked. But when you open the first web page, it redirects you. It may have a minimum of an acceptable use policy. I promise not to do the following things. It may make you put your email address in. It may make you sign in, username and password, or it may make you spend some money and buy some credits. Now, all of these are effectively a captive portal that is put on your local coffee shop, for example, and basically it's for legal protection. You've promised to not download BitTorrents or illegal materials. So if you do, it's on you, not on the coffee shop. Now, when you sign in, either with WPA2 Enterprise, 802.1x EAP radius, what happens is, as a successful result of your sign-in authentication, the client, which is sometimes called the supplicant, and the wireless infrastructure, which in this case is called the authenticator, they create a master session key. In fact, the master session key is downloaded to the authenticator. It doesn't generate it. The security takes place between the client, the supplicant, and the radius server. Okay? So the MSK is chopped in half to create the pairwise master key. That is downloaded to the access point, to the wireless LAN controller and the access point. The supplicant calculates it itself. Now, if you're using WPA2 personal pre-shared key, what happens is the passphrase is mixed 4,096 times with the SSID to create the pre-shared key. Pre-shared key is again chopped in half to create the pairwise master key. So the pairwise master key is either gotten from half the pre-shared key or half the master session key, the MSK, from 802.1x EAP radius. Now, key point. When you use WPA2 Enterprise, 802.1x EAP radius, you get a new master session key every time an individual logs in. You log on at 9 o'clock, you disconnect, go for a coffee or for lunch, come back and log in, you get a new master session key. Right? You use a pre-shared key, WPA2 personal. The pre-shared key, because the passphrase is the same, the pre-shared key is the same every time. So every time anybody on your network with a pre-shared key, anyone on an SSID logs in, they are using exactly the same PMK. Okay? So if we break the PMK, we own your network. If you break the PMK with 802.1x EAP radius WPA2 Enterprise, you get a new PMK every time anybody logs on. That's why Enterprise, WPA2 Enterprise, is so much more secure than WPA2 Personal. Okay? So everyone uses the same pre-shared key. Okay. once you've gotten the PMK, what happens, I want to go back one slide. I can see some questions coming in, and I will open them up in a minute. Once you've got the pairwise master key, you do the four-way handshake. If you don't do the four-way handshake, you've got no encryption. Okay? So the four-way handshake gives you encryption. The four-way handshake, in handshake number 1, the access point sends down its random number. So what you need to create the keys that we use for security, this is called the pairwise transient key. It's actually split into 4 parts, and the temporal key, you may see it called the temporal encryption key, the TEK. It just depends whose book you read, it doesn't matter. Same name. That's used for the encryption. It's gotten from the pairwise transient key. The pairwise transient key is created from an algorithm using the PMK, the supplicant's random number, the access point's random number, the supplicant's MAC address, and the access point's MAC address. Okay? So the authenticator, the access point, sends down its random number in exchange number 1. The client, the supplicant, sends its random number in exchange number 2. Now, after exchange number 2, you have everything you need to create the pairwise master key. Now, anybody watching this over the Wi-Fi network will see 1, 2, 3, and 4 go by, but they don't know the pairwise master key. Okay? That's the key thing, if you pardon the pun. Okay? Pairwise master key never crosses the Wi-Fi network, so it's not known. So you have to attack the pairwise master key. And what you can do is you can see exchange number 1 and 2, and you get this information. And what happens in exchange number 2 is this key, called the KCK, is used to create a MIC value. And a MIC value is created in key exchange 2, 3, and 4. Now, the MIC value is kind of like a fancy CRC. I don't mean to do it a misjustice and be disrespectful. It's more than that, but effectively, if you understand what a CRC is, that's what the MIC value is. It's a value created based on the information in the frame that is used to protect the frame. So if you change 1 bit, the MIC will be invalid. And the MIC is calculated for exchange 2, 3, and 4. The other key, the KEK key, is downloaded. Sorry, the KEK is used to encrypt the broadcast key that is downloaded in exchange number 3. And then exchange number 4 is the client going, yep, we good, rock and roll. So a lot of people don't get this, but if I'm creating individual keying, which is the ultimate goal of this, everybody gets their own encryption key, because if we, like WEP, if we have the same encryption key, I can decrypt your data, right? If I work for the same company and I have the same WEP key, I can decrypt your data. So what WPA2 Personal does, and Enterprise, is it creates individual keys that only the access point and the supplicant know. So it's per session, per client keying, encryption keying. Okay. So what we do is we don't try and attack and break this key. We try and break this key by guessing what the passphrase is. There's only 2 ways to do that. A dictionary attack, where you create a load of words and you try them, or a brute force attack, where you start off at A. Now, there's a minimum passphrase of 8 characters. So you start off at 8 A's, then you go 7 A's and a B, 7 A's and a C, and then eventually you go to B, 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 A, B, 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 and you go through every possible combination. Okay. And what happens is password attackers will either read from a dictionary file, and a dictionary, remember, it's not like Webster's dictionary. A dictionary is a list of words, and they may be words and numbers. They're not real words. It's called a dictionary because you're using it as an input to the password. And you try this word, it's not true. Try the next word, it's not true. Now remember, the passphrase is mixed 4,096 times with the SSID. So you don't just go bang, 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 bang. You go bang, 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 bang. It takes time for every word you want to try, whether it's created from a dictionary file or created from a brute force attack. It takes time to create the pre-shared key. The pre-shared key is not the passphrase. The passphrase and the SSID are mixed to create the pre-shared key. So if you have the same passphrase on two different Wi-Fi networks, you end up with a different pre-shared key. Okay. So remember, what does our little Pwnagotchi do? It captures WPA handshakes. So it will capture these. Now, you learn very quickly, it doesn't need to capture all of these. It just needs the first two. It just needs to get the random numbers. At the end of key exchange number 2, it takes what it thinks the passphrase is, mixes it together with the SSID, comes to pre-shared keys, creates the PMK, calculates what the MIC would be with the information it's got in exchange 1 and 2. Does it match the MIC that was transferred? No. Then it's not that passphrase. Next word. Next word. Next word. Eventually, oh, it matches. Now we know what the passphrase is. So that's what the Pwnagotchi does. It captures these four-way handshakes. And it will also associate with the AP to try and get a PMK ID attack. And it will de-authenticate the client. And the client will then go, oh, I've been disconnected. You know what? I'm going to reconnect. What does it do? It reruns the four-way handshake. So the Pwnagotchi will sit there and wait for four-way handshakes. If it doesn't see one, it will give the network a quick slap, and it will disconnect the client, for example. And then that client will immediately reconnect, and the Pwnagotchi goes, ha-ha, gotcha. And it's then got a four-way handshake. Now, warning, if you allow de-authentications, that is a very gray area. And as the Pwnagotchi becomes more and more popular, you may find the authorities may want to give someone a slap to warn people to not do this. I don't think anyone cares if you de-authenticate in your home network. The problem is, if you turn off de-authentications, okay, it will still capture if it sees data go by. So you're going to learn in a little while, you can whitelist in the config file saying, do not attack the following networks. And that actually turns off de-authentication. If it's on channel when a four-way handshake goes by, it will grab that four-way handshake quite happily. So, you know, you may get the airport, the police station, the fire station, blah, blah, blah. You may get those captures as they're transmitted. All right. I did promise that I would have a Q&A session. So let's stop there for a quick break. Guys, Rod, I'm assuming you're more than happy to leave the recording going for Q&A. Might be interesting.
Sure. I mean, go as far as you want. It's all right.
Yep. So my screen's gone blank because I'm no longer on my PowerPoint. So do we have any questions?
Yeah, we do. Do you want me to read them to you, or you want to read them?
I can see the chat. Let's do the ones in chat first, then. But
yeah.
there's also,
go ahead.
There's also a QA somewhere, isn't there? So here we go. Yes, it works perfectly on a Raspberry Pi. Now, full disclosure, it is written for the Raspberry Pi 0W, but I've had no problems running it on a Raspberry Pi 3B Plus or a Raspberry Pi 4 other than power requirements. How do you recommend protecting a Wi-Fi network from a Pwnagotchi? What a fantastic question. Use WPA3. Now for that, you need client and infrastructure to support WPA3, which is not quite here yet. In reality, the only way to use WPA2 and not be susceptible to a Pwnagotchi is to use WPA2 Enterprise. But for that, you need a Radius server and an infrastructure that supports it. Now, before we move on, there's a huge warning. for WPA2 Enterprise, right? Some people do things without fully understanding, okay? When they configure WPA2 Enterprise, and they then come to the point where they need to get a certificate on the Radius server. They're like, oh, this is hard. It's going to cost a lot of money. I'll tell you what I'll do. I'm going to go into Microsoft or Apple or whatever, and I'm going to say, do not validate the certificate when it comes down. Now, you just did the dumbest thing you could possibly do. You have just made your network less secure than web, right? A black hat can inject man-in-the-middle attack onto your network, give you a false certificate. Your client's going to accept it, not check it, and you are doomed. So WPA2 Enterprise is only secure if you do it properly and you use certificate validation in the way it's supposed to be used. You use like EAP-PEEP, EAP-TLS, Cisco proprietary EAP-FAST. You've got to use one of the good EAPs, okay? So, and that is a lot of work, but don't think that's easy. First of all, the infrastructure's got to do it. If you're thinking about doing this at home, then give it up, because most small office, home office devices, even the ones you buy down the retail store, may not support WPA2 Enterprise. Okay. In that situation, you may have to start looking at, what's it called, DDWRT. Have I got those letters in the right order? You may have to look at DDWRT in a home-built kind of environment, because that can be configured for WPA2 Enterprise. Now, WPA3 is around the corner, but it's been around the corner for 6 months. You have to buy clients that support it. You have to buy AP infrastructure that supports it. WPA3 is going to save us. And I did a talk at the Pacific Hacker Meetup on how WPA3 isn't as broken as everybody says it is. Okay? It's not that broken if you configure it properly. Okay. All right. Got how many milliamp hours do we need? So you're looking at, so there's two questions there. The amperage you need is 2.4 amps. I believe 2.5, I believe, for the Raspberry Pi 3. I'm not sure what the 4 needs, but it's a bit more because it's got the fan and it's got way more memory, graphics processors, CPU power and things. The Raspberry Pi W should work below 2.5 amps. Should work. I've got it working on, I think, a 2.4 amp one. It doesn't use 2.4 amps. I think my little reader may have said 1.5. I won't swear to it. We're going to have to check on this. But the Raspberry Pi Zeros are a lot less power hungry. Now, the other side of the question you've got is, when you multiply the milliamps by time, you got milliamp hours. So the bigger your battery in milliamp hours, the longer it will power the device. So if you're trying to run a Raspberry Pi 4 off a battery, it's going to have less time than the Raspberry Pi Zero W will have. So the ones I'm using are like, I think like 20,000 milliamp hours. The little one I mentioned with the USB-C recharge, that was 15,000, I believe. The problem you've got, of course, is now the Raspberry Pi Zero is quite small and fits in your hand, but the battery you're running off is now the size of an iPhone, and it's 2 to 3 times the thickness of an iPhone. That's the problem, right? The more milliamp hours you get, the more power it will give you, but the bigger the battery. So what differentiates Pwnagotchi from a Wi-Fi Pineapple? So I do a lot of Wi-Fi pen testing classes, and the Wi-Fi Pineapple is a great learning tool, but it is a very basic learning tool. Okay, You press a button and something happens. It is not really very well respected in the hacking industry. And let me see if I can show you. Now, okay, I'm not going to show this because there's an awful lot of cuss word on this. I will leave this up to you. Google DEF CON I hunt pineapples. There's someone going around DEF CON who looks for pineapples and bricks them. Okay? Now, adult warning, there's a lot of cuss language or when you find the page, but basically it's like I hunt pineapples. Hey, you come to a hacking conference and you buy this and you turn it on and you try and mess with us. Well, if you're really that bleepity bleep hot hacker, you'll be able to undo what I just did to your pineapple in essence. Now, there's a lot of hackers, white hat, we'll call them, white, gray hat, whatever, good guys, good gal hackers at DEF CON who laughed when they saw this. And a lot of people I respect, and taking a pineapple, or a Pwnagotchi for that matter, to DEF CON is like walking into a dojo, now you've got your yellow belt, and challenging the black belt to a duel, right? So conceptually, it's similar to a pineapple, but a pineapple is a point and click, okay? I don't teach pineapples in my pen testing classes. I teach M1NGs and other utilities, because the pineapple can only go so far. A pineapple can do other attacks over and above the four-way handshake attack. It's got a repertoire of other things as well. And great learning tool. I own one. I just haven't turned it on recently. The Pwnagotchi will just capture four-way handshakes. Okay. Now the Pwnagotchi capturing a WPA2 enterprise four-way handshake isn't really going to be able to do much with it. It's really targeting WPA2 personal. Okay. Deauthentication. Deauthentication is when I tell you to disconnect. So deauthentication is what is known as a spoofing attack, because I send a message from what appears to be your AP to you saying you're disconnected. And you're like, oh, okay. Then I'll reconnect them. Nothing stops you reconnect, but when I deauthenticate you, I pretend to be your AP. Okay, so I send the source address from your AP. You disconnect, then you immediately reconnect. When you reconnect, you redo the four-way handshake. So the reason we do deauthentication attacks is to make you redo the four-way handshake. Yes, I hunt pineapples. Now, that's all I'm seeing in the chat questions. Do we have some Q&A questions? John?
I have a question for you, Philip. I noticed testing on my, I have different types of access points. And I noticed that the latest ones, like the Google ones, for example, is very hard, is really very hard to authenticate. And most of the dictionaries do not have the actual password. Have you used, yeah. would you prefer to use Rainbow Tables instead? They sell like a full hard drive with Rainbow Tables in Hacker's Warehouse, for example. Yeah, go ahead.
So the problem is the let me show this. So this is the problem, Rod. The passphrase is mixed 4,096 times with the SSID. So technical mode on, the WPA2 personnel pre-shared key is a calculation of, what's the name? I forgot the name of it. It's a well-known algorithm. Forgot the name of the algorithm, but it's based on a well-known algorithm that salts. It uses a salt. Okay, so is it a PMBKID? Am I making that up? Maybe. It's a well-known algorithm, but the salt is the SSID. So the rainbow table is only useful if, let me stop and go back. So if there's 20 million words in the dictionary, if you create a rainbow table on those 20 million words, you have to have made it for every single SSID. So if I change my SSID to be FBI Net 3, and you've created the rainbow table on FBI Net 2, the rainbow table is of no use. So the rainbow table has to take into account the dictionary and the SSID, because the SSID is used as a salt on the passphrase. Does that make sense?
Yeah. A few words. This is, you can use, like if somebody that has, if you're in an engagement and they have randomized well enough the password, like for example, they put either spaces or special characters, this is simply not possible. You had to basically get aggressive and de-authenticate. Am I correct?
So let's say I'm attacking you on a pen test gig. If I know what your SSID is, I will create a rainbow table, and you can do this very easily using utilities in Kali Linux. I will use a rainbow table on the RockU text dictionary, for example, on your SSID. So I can create a rainbow table, and I show this in my pen testing class, and I think I showed this on the talk I did at the thing last fall. It took me using, so I used two words. I had two networks, network 1 and network 2. Network 1 used Candy123 as the password, the capital C, which is 700 words in the dictionary. My Raspberry Pi broke that in 3 minutes. Network 2 used QtPi7 with the capital C, which is 7 million words in the dictionary file. It took my Raspberry Pi 6 hours to break that password. Yeah. I then took them offline and I created a PMK file using those SSIDs as seed values using Gen PMK on Kali Linux, and it took 15 hours to create both of the rainbow tables. But I did that in the comfort of my house.
Right,
when I then
you were using the AI backend, right?
What do you mean by the EA? So the EA backend?
The AI backend, the deep learning.
No. I just created I just went through every possible value of the RockU.txt password, and I pre-coded it for the SSID that I was using.
Okay.
And that took 14 hours to run through the entire table. When I then attacked using Kalpati, using the PMK, using the rainbow table, not the password, it broke Candy123 in 0.27 seconds and QtPi7 in 5 seconds.
Okay.
But I had to pre-compute those rainbow tables for every SSID. So if I now go to a new customer site and I want to use the rainbow table on the RockU.txt, I've got to pre-create it with their SSID. So I can't reuse a rainbow table. Now, you're a smart guy, Rod. I know that you're going to think up a password and you're going to grep it on the RockU.txt file. Let's say you want to use umbrella 7. You're going to go and see, is umbrella 7 in the RockU.txt? Oh, it is. So you're going to call it umbrella 72. Is that in RockU.txt? No. Well, you've now completely stopped me in my tracks, because now I can't use a dictionary file. Now my only choice left is a brute force attack.
Right. Right. That was actually that's actually a better framing of the question. When you are in environments, because the easy ones are easy, but I'm talking about like in a higher level security. For example, the people that have some knowledge of the dictionaries, like you just said. So I purposely would input things that I know they're not in the dictionaries. How would a device like this will help?
So it will capture the four-way. If you capture the four-way handshake, you can do a brute force attack on it. Now, you got to throw processing power. That's what we're going to talk about at the end, Rod. You got to throw processing power at it. So just to give you an example, my little mining machine, my little baby Kraken, it broke Candy 123 in 30 seconds. I used a more complex password of 8 characters, and it told me it was going to take 8 hours. Now, normally when you do a random password attack, you assume 50% of the search space, right? And I'll show you the maths at the end of how to calculate it. But it's back to the old age question, which is better, complex or longer? And I prefer to make it complexly longer. So you'll see when I make it a 9-character password, not an 8. It's not 8 hours anymore. It's several days. If I mix it up so it's uppercase, lowercase. Oh, by the way, just to give you a heads up, it's 8. I'll show you the math later. It's 8 hours when I tell Hashcat it's uppercase, lowercase, lowercase, uppercase, lowercase, number. That's still 8 hours. Just letting Hashcat go at the 8-character password it told me it's going to take 101 days. But I've got 1050 Ti's on a baby Kraken. Real criminal hackers will have 2080 Ti's meshed together with Linux on real Krakens, which are like 10 times the power. So simple maths, 101 days now becomes 10 days. So basic rules, if you make your passphrase 13, 14, 15 characters long, and if you make it 14 characters long, 15 characters long, it's going to take a long time to break. If you throw in complex characters and you write it down somewhere and keep it in the top drawer, you've made it insecure because it's easier for someone to break in. There's a KC, what is it? I've gone blank. KFCD cartoon where number 1 said to number 2, oh my gosh, we are never going to break this. This is 4096-bit RSA crypto. And in the next slide, number 2 turns to number 1 and says, right, hit him with this wrench until he gives you the password. It's one of my favorite cartoons because, it's going to take 1 million years to break it. Well, let's just hit him with a wrench till he gives us what the password is. That's an XKCD. Thank you, Howard. Yeah, I'm getting my words wrong. It's an XKCD cartoon which shows the point, really, right? So really, it's about making it complex. And what I'm showing you here, we're capturing the pre-shared keys, but you're not breaking these in seconds. You've got to throw some resources at breaking the keys. Does that answer that question, Rod?
Oh yeah, absolutely. So I guess that's what they are doing with this very string keys that they put in the cable routers, right? Although I did find a cable router dictionary.
Well, the long keys. So there's 3 ways you can enter a pre-shared key. You can enter a passphrase. You can enter 63 characters, or you can enter a 64-byte hexadecimal string. Now, when you enter a passphrase, you can enter like "let me in." That mixes that with the SSID. When you enter the 64-byte hex, that is the pre-shared key. But it should be gotten from the SSID. Does that make sense? Right. Someone's just mentioned I seem to have a problem with a string of letters today. I couldn't remember XKCD and I couldn't remember PBK DF2. That's exactly what I was looking for. So if you want to know what the pre-shared key is based on, it's the PBK DF2 algorithm. And it uses the SSID as the salt value.
I see. Thank you.
So somebody says, what is DDWRT? DDWRT is a Linux-based kernel you can download for the majority of access points. If they don't have a standard release, somebody somewhere is working on a beta release for your box. I quite happily use a beta release on my old Linksys machine. Most small office, home office routers, I call them routers. I do know better, but I'm simplifying the words. Wi-Fi routers we have at home, they have a subset of functions for the home environment. DDWRT will open up a lot more functionality, but you have to download it and you have to rewrite the flash of the Wi-Fi router. Okay. Now just Google DDWRT and you type in your router. Now if you don't get any luck, Google DDWRT with the model number of your router and you find someone is probably working on it. Yeah. Marco's just posted the router database. Oh, that's a good question. When using WPA2 Enterprise, can a Pwnagotchi deauthenticate a client and force it to redo the 4-way handshake? Yes. But when the client deauthenticates, it will want to do a full to the 1x EAP reconnect, and that will give it a unique PMK. Now, if you have fast roaming, fast transition 802.11 RKV turned on, that will do a fast roam, which will run the 4-way handshake from the same PMK, but that PMK is not going to be a string of words. It's going to be a 64-byte mesh of numbers. So if you want to try and brute force attack a WPA2 Enterprise connection, you're going to be attacking 64 bytes, which is going to take you like 1,000,000 years or something. Oh, someone's mentioned you've also got OpenWRT, and more today, there's less devices being supported. Newer APs don't necessarily have support for DDWRT or OpenWRT because of requirements of the FCC, and also if you go and if you buy like 11AC routers, Wi-Fi routers, they also tend to have stronger requirements and may not necessarily have code available. How widely is management frame protection supported? Great question. It's the vendors support it and some clients support it. But oversimplifying this, the only way you can make the 802.11w work is to have every single device on the network supporting 802.11w. So if some devices don't support 802.11w, you can't use 802.11w on that network. Oh, well, yes, you can, Phil. You can make 802.11w optional. Yeah, but then the network isn't 802.11w, right? I'm not going to attack the 802.11w part. I'm going to attack the non-802.11w part. And then the client that doesn't support 802.11w will be allowed to connect, and I'll deauthenticate him, then I've got the 4-way handshake. So the only way you can make 802.11w work is to have it mandatory 802.11w, and then every client has to support it. So That 5-year-old laptop that's still used in the warehouse probably won't support that, and that's the problem. Yes, is it possible to make a WPA2 client personal, a WPA2 personal client smart enough to notice that it's been repeatedly forced to redo the 4-way handshake? Yes, but that doesn't fit in the IEEE rules of 802.11, and no vendor will do it because they don't want to spend the money on it. The solution is WPA3 with 802.11w. That's the solution. And it's coming. Now, I need to make you all aware of something. If you don't hang out in the wireless circles, you may not know. The key things we are using today are 802.11ac, 802.11r, 802.11k, 802.11v, and 802.11w. We are now about to start using 802.11ax over the next year, and we will then move into the Wi-Fi Alliance certification, Wi-Fi 6, which is 802.11ax, and Wi-Fi 6E, which is the new frequency of 6 gigahertz the FCC about 2 weeks ago gave us. Okay? Now, 802.11r, 802.11k, and 802.11v were created as amendments by the IEEE somewhere in the range of 2009 to 2012. So here we are in 2020 talking about turning on KRV, and pretty soon all the clients will support them. We've had these for 8 years, maybe more. The point is, it's the field of dreams. If you build it, they will come. The vendors won't start building it till there's some clients that support it. The clients won't start doing it till there's some vendors that do it. Usually the vendors do it eventually, and then we get some clients. I have a Samsung S10 that is WPA3, KRV compatible, W compatible if I remember correctly. I want to buy a new iPhone which does the same. But if you have a device that's maybe more than 2 or 3 years old, probably doesn't support KRVW. I think iPhones do. Apple very quickly went to KRV. And that's the problem. We have the protocols that will protect it, but your boss, CTO, your boss, he or she isn't going to mandate that we upgrade everybody's phones, tablets, and laptops tomorrow to the 2020 standard. We slowly do it, right? Most companies have a 4-year buy cycle. Well, see, great question. In my experience, some Wi-Fi clients, especially embedded, refuse to connect whenever 802.11w or WPA3 is enabled, even if optional. Yes, that was the problem. The problem was the driver writers did it wrong. The rules of 802.11 are, if you don't understand an information element, you ignore it. Well, some devices went, oh my gosh, you've turned on and haven't turned on 802.11w. I'm not going to connect to that network. Absolutely. This is a known problem about 2-3 years ago. Now, the other problem we have is, if you think that all the vendors and the clients and the IEEE and the Wi-Fi Alliance are one big happy family who all agree on everything, I have some really bad news for you. The good thing about standards, right, are there are so many you can choose from. I'm supporting a major vendor network with Apple clients. It turns out that Apple fixed the way they deal with 802.11 KVR. All Apple devices stop roaming on the client's network, and this client relies on Apple devices. We call up the company. Oh yeah, it's a known bug. We and Apple did it wrong. Apple just released it, doing it right. Our release is coming out in 3 days. The fix was turn off KRV, and it worked. 3 days later, we updated the software. The problem was that Apple and this large vendor didn't agree on releasing the code update at the same time. And what happened was Apple did here's a new version of Apple software, and all the people in the company were like, hey, there's a new version of Apple software. Do you want to upgrade? Sure. Stop the clients working for 3 days. We turned off KRV for those 3 days. We did testing on the vendor's new software, like we do. We thought it was acceptable. We rolled it out, turned on KRV. 3 days later, everybody's happy again. This is the problem, right? You got all these letters. Now, I'm only seeing chat, by the way, Marco. Is it a Q&A session as well?
No. So whatever they put in the chat, you know, that's it basically. So if you want to continue your presentation, and then maybe at the end we'll answer the rest.
I do want to take a quick comfort break and fill up my coffee pot, and we've been going for like an hour and a half now, so I think everybody might appreciate that. Let's just take 5 minutes, stand up, stretch, have a comfort break. Rod, can we pause the recording maybe?
Yeah, I can do that, no problem.
So let's just take 5, team. How am I doing? Where am I?
Go for it.
Some more questions just come in. Number 1, should I add to my resume Pwnagotchi experience because it may be illegal? The answer I give is you don't say that I've got experience hacking Wi-Fi networks with Pwnagotchis. You say I have experience pen testing Wi-Fi networks with Pwnagotchis, and that's your get out of jail free card. Dave asked a question. I just checked the latest iPhone, iPad tech specs. It says 802.11ax Wi-Fi 6, but it doesn't mention W. I believe, I will have to check on this, but I believe that AX mandates WPA3. WPA3 mandates 802.11w. I can check on that later, Dave, but AX, I believe, mandates by inference 802.11w. You've got to turn it on, of course, but it should be supported. So if you buy a client at 802.11x, sorry, 802.11ax, it should support 802.11w. I'd be very surprised if it didn't, that it'll be hidden somewhere in the paperwork. All right. I understand there's lots of questions and people are keen. We've got to get slides up. Can you mute everybody, and I can start my sharing again? Okay, here we go. So we got to the end of the 4-way handshake. This is a great topic. We can talk about this for hours. And if you want to start learning about pen testing Wi-Fi, get a Pwnagotchi or get a Pineapple. Now the Pineapple's got a bit more of a learning curve, but it's similar attacks, right? On the Pineapple, though, you press a button on the control interface and it does the attack for you. The beauty of the Pineapple is you don't need to know what you're doing, which could also be a little bit of a dangerous thing, right? But just be aware, don't go to DEF CON and start running Pwnagotchis and Pineapples. I would also be very careful about running Pwnagotchis as well. Well, we're not going to have a chance this year because it's cancelled, right? I was, start of the year, I was thinking, oh my gosh, I've got 4 conferences in Vegas this year. Wow, am I going to spend a lot of time in Vegas? And the universe said, no, you're not. And that was the end of that Vegas trip. All right. So the display. Now, I'm not going to go through all these. I just wanted to show them and try and do my best to include them. I've gotten this from the Pwnagotchi AI website, okay? So I'll show you some of the more normal ones, but I'm not going to go through every single one, okay? So you can see awake and normal. It really is quite cute. My wife loves it. It was crying. She's, what does that face mean? I said, it's crying. And she was, oh. So you've got awake, observing, intense, cool. Okay, I like cool. Happy, grateful, excited, friendly, motivated. Then you got bored. And then, of course, there's the crying. And then, of course, then there's the lonely one. And come on, oh, now, how many of you went, oh, when you saw lonely on the screen, right? Now, there is a known issue with it where it breaks and stops recognizing network traffic. It's known as the blindness bug. You've just got to reboot it. So let's go through the display. Here we have the Pwnagotchi, and it's telling us information. First of all, it says, I'm currently on channel 1. Nice and simple. Now, if it ever shows the star, that means it's hopping, doing recon, looking at what's out there. Okay? So channel star means it's hopping around, doing recon. Now, here's the number of APs on the channel. Now, if you don't know much about Wi-Fi, having 14 APs on channel 1 is a problem, right? But that's 2.4 gigahertz. That's what you're stuck with. There's 14 APs on channel 1. Now, the total number of APs discovered on all channels during the last recon is 45. That's what that number says. Uptime is the uptime since the last reboot. Very simple. So if you see 36 hours, actually I may have misspoke earlier. That's hours, minutes, and seconds. Earlier on when I saw something, I think I saw 7:04 and I said 7 hours, 4 seconds. No, that's 7 minutes. So this is 9 hours, 18 minutes, 49 seconds. If you see like 40, 03, 07, that means it's been up for 40 hours. If you never see it go more than 03, 05, or 06 or something, that means more than likely it's not getting enough power and it's restarting. There's your name of the Pwnagotchi and the current face that it's displaying. Now, if you look at the screen, you will see a little ghosting. There is always ghosting on these screens. It depends on the brand of screen you buy and the luck of the screen. Some of them have less ghosting than others. This particular WaveShare screen is one of the better ones in general for less ghosting. You've also got a status message where it tells you what you're doing. It can also say there, found, hey, and it'll give you the BSS ID of the network it's just discovered and things. Now, down here you've got the pwned info. Okay? The number is how many handshakes it's pwned since the last, or pwned. I have a funny Welsh accent, so some of you probably sat there giggling by my pronunciation of the word pwned, but whatever, right? Yeah. I have a funny, I don't think I have an accent. It's all you all have accents, right? And we all think that. So I pwned 12 networks since the last reboot. Total ever, 79. The one in the parentheses is the total since the unit was born, since it first ever woke up and Googled. And here's the recent SSID handshake that was acquired. The mode, I'm going to make you wait till later for that. Now, here we see that Merlin has got a friend it's found called Myra. Okay, it shows you what face Myra recently showed, the signal strength between them, and the pwned info from Myra. Same as down here. Since last reboot, ever. Now, I don't want to go into too much information now. It is on the Pwnagotchi.ai. When two Pwnagotchis become very good friends, they do have the ability to slice and dice up the channels between them. Okay? That depends on the AI algorithm and whether it's running and how long they've been together and how good the friends they are. Now, they've got to be very good friends for that to happen. Now, the Pwnagotchi, by the way, will only show one friend here. And it's the one they see the strongest value, strongest signal strength. So this guy may have, he may be friendly. I know they are. You can connect to the web interface of the Pwnagotchi and you can see all the friends on the web interface. And I know that all 4 of mine are friendly with each other. They got another guy as well called Pwnagotchi, which is probably yours, Howard. Probably yours, yeah. So mode. The mode is one of 3. Now, from the perspective of the Raspberry Pi 0W, there are two interfaces. If you plug into looking down from the top like this, the one closest to the left-hand edge, that is power only. What will happen is your Pwnagotchi will start up, screen will flash maybe, and it'll come up, and you will see auto. You get auto usually for a little while after you've started up the Pwnagotchi. Then, unless it's been turned off, the Pwnagotchi will start doing AI. So here, for example, you can see we're 16 minutes into the life cycle of this boot to the Pwnagotchi, and here we're 9 hours in, and this one, it doesn't take that long. The longer you leave it up, the more likely it is to go into AI. Now, it only does this if you're still on the leftmost one. Same one, right? And that's power only. Usually, the Pwnagotchi will transition into AI and start learning after a few minutes. Now, if you plug into the data port, data and power, your Raspberry Pi 0W will come up in manual mode. And that little joke here, no, not the English football team. Anybody who's been to England knows who Man United is. If you connect to the data port, hold up. You can't just plug in a cable into the data port. It has to be a data-capable cable that gets plugged in. Then the Pwnagotchi will start up in manual mode. What it will do is it will tell you a quick summary of what it's done recently. So here you can see this guy in the last reboot learned one new handshake. Now, it's made zero new friends because it already had them as friends. Okay, and it's kicked 0 stations off. Now, that may not be because it's not working. It may be because all the networks it's seen, it's already kicked off before. Now, from manual mode, you can extract the data, the 4-way handshake. Basic configuration in 1.43 was done with a YAML file. I'm sat there trying to get the YAML file working, and it's not working. One of the big problems you've got is spacing matters. If you've ever worked with YAML, spacing matters. So I try and get it working, it's not working. I'm sat there now really disappointed that my YAML file won't work. And I'm on my Apple Mac, and I'm looking at the file, and it's called config.yml. And I'm like, let's see if my Mac is deceiving me. And I go into command mode, terminal command mode, and I type in ls, and it's config.yml.txt. And I will admit to you that a swear word may have been uttered under my breath. Just be aware whether you're on Mac or Windows. I thought about this, and I thought, no, Windows will do this, but Mac shouldn't do that. Yep. Mac was hiding the .text from me. And the reason that my YAML file wasn't working, because it wasn't a YAML file. I renamed it in the terminal window from config.yaml.text to config.yaml, loaded it on the SD, and immediately it starts working. And I find out that I've wasted a couple of hours trying to debug what the heck is going on, right? So basically, you can manipulate the UI. You can configure. Oh, excuse me. There you go. So here, for example, the default, by the way, is the WaveShare _2. If you want to use the WaveShare 27-inch, you can manually type this in here. Now, you can, by the way, on the Pwnagotchi AI explains this, you can go into the config file that is created inside the Pwnagotchi file structure and manipulate these as well. So you don't have to try and get it working from the .yaml. Now, the other thing to be aware of, as of 1.5, it's become a .toml. Okay, it's not a .yaml anymore, it's .toml with the 1.5. Now, I haven't played with them at all, so I can't comment on that. You can get really carried away. You can create whitelists. Now, whitelist means you will not attack these. You will not de-authenticate these. You can change the operation of the display and the faces. Change what the faces do if you want to. You can get to this level of detail. Very, very customizable. Okay, now watch out for this. If you do the whitelist, that means you will not deauth them. If you're on a channel and you see a four-way handshake go by, you will capture it. One of the biggest questions you can see on Reddit and on other forums for the Pwnagotchi is, why is it that I put my network in the whitelist, it's still capturing my four-way handshake? And it's because of this. It will capture the four-way handshake. It just will not deauth. Okay? Now, another word of warning here, be careful with the Pwnagotchi. By default, grid is on, and grid means your Pwnagotchi may try to register up to the database of Pwnagotchis in the world. Okay? If it successfully gets an IP address on the internet, it may start talking to the internet. Just be careful, you know that it's doing that, a word of warning. Okay? It will exchange information with the internet. Read this on Pwnagotchi.ai. So if you do give it an IP address, just be aware, by default, the grid option is on, which means it will try and connect. Okay. Connecting. So here, if you're using a Raspberry Pi 0W, you connect in via a data cable to the data port. Okay. When it boots, you should get a new interface on your laptop. I got the new interface on my Apple. I never tried it on Windows, but I believe it's the same. Okay. If you don't get the new interface that comes up, change the cable. Once you've found a cable that works, keep it safe. Okay, it's worth its weight in gold. A lot of cables that are sold on the internet are power cables, not power and data cables. Basically, it's got two of the pins missing. Also, I found when you buy the Raspberry Pi kit, the case kit, for example, or you buy it, I like Canna kits. I really like them. They're really good. It comes with a little USB power switch. If you plug a data cable into the power switch, the power switch may not extend the data cable. Watch out for that one. Okay. So you configure your laptop with a 10.0.0.1 IP address, /24 mask, and the gateway you point to yourself. The Pwnagotchi will be on 10.0.0.2. So now you simply, from the command line, SSH into, or from your GUI, whatever, you SSH into Piat 10.0.0.2. Password is Raspberry. The default top tip, you probably want to change this, especially before you take it to DEF CON, right? What happens now is this appears. Comes up like this, you know it's ready, and you know it's got an IP address. Now you can HTTP over to, if you HTTP over to the IP address, you will end up at the BetaCap webpage. Okay. Again, standard password, username, password, you might want to change them. If you go to port 8080, you will end up on the Pwnagotchi webpage. And it's got information there about what the Pwnagotchi has done. It shows you how many friends it's made. It shows you if you got Pwnagotchi mail from connecting up to the Pwnagotchi mothership, as it were, and so on and so forth. Now, if you do this with a Pi 3, a 3B, or a 4, it doesn't work this way. This entire construct is Raspberry Pi 0. The 3 and the 4 do not have a second data port connection. So you simply plug the Pi into the Ethernet network that the PC is on, give it a DHCP address, and then you can SSH to the IP address. I have a little switch and little router I bought off Amazon for 20 bucks, and that gives out DHCP addresses, and I connect them together in a little closed loop, excuse me. And so I don't give them internet access. Just be aware, if you plug this into your real Ethernet network, your Pi will get a real IP address and may start connecting up to the Pwnagotchi mothership. Okay? You simply SSH now to the IP address just like you did here. Okay? Here. You can SSH over to the Pwnagotchi. The difference is when you do this on the Raspberry Pi, Pwnagotchi is in manual mode. When you do this on the 3, 3B, or the 4, the Pwnagotchi is still in operational mode, scanning. You can also, on the Pwnagotchi.ai website, it talks all about this, you can tether using Bluetooth. So you can, as you walk around, you can gather information from your Bluetooth connection. Go to this web page and go search for Bluetooth. It tells you how to do it. Now, just watch out. The entire Pwnagotchi.ai web page is now 1.53, 1.5.3 compatible, all right? I don't know if you can get to the old 1.43. I've never tried. So if you do go to the new Pwnagotchi.ai, it is already up to 1.53 version. All right. So now you've got to get off all these four-way handshakes. I'm showing you the easy way to do it. I struggled getting it from the folder in which the handshake was stored. So I came up with a real easy solution. Okay, I SSH the Pwnagotchi. I then copy the root handshakes from the root folder, okay, to the current folder. So actually, I think I missed out a step here. Nope, I didn't. I sudo copy from /root handshakes to the current folder, so it creates a handshakes folder in your Pi users home folder. Don't forget to do -R. I exit out to the PC, then you simply secure copy Pi at IP address /home/Pi handshakes /star.star to the current directory, and now is another step. So on your local PC, just make a quick directory and change into it, then run this command. Password's Raspberry. Now note, some of the files may be 40 megabytes or so. So you download all the captured handshakes, and you will have handshake files even if the Pwnagotchi hasn't captured the handshake. It will try and associate to the AP to try and get the PMK ID. So if you open the PCAP and it's only got 104, 104, 104, 104, it hasn't captured the handshake. Usually you need to see 104, 204 at a minimum. That's a handshake. All right. Do, hammer time. I'm obviously showing my age. There are people out there going, what's hammer time? Obviously, I'm a child of the 80s, as you can tell. So you've got to convert the file to the hashcat format for it to run on hashcat. So you download the utilities to do this. This may require some compiling and other dark magic. If you're like, oh, I'm scared of that, I don't want to do that, fine. You can upload your PCAP if it contains a capture of the four-way handshake. You can upload it to this website. It does have a 20 megabyte limit. Okay. You click a button and it downloads a converted file ready for hashcat operation. You get this file onto the hashcat server, and in the words of Picard, number 1, engage. Just do it, right? Now, obviously, when you're doing pen testing, you don't care there's an audit trail. If you accidentally capture the police department's four-way handshake and upload it here, there's going to be an audit trail of what you did, okay? So just be careful. It's all fun and games until it's not. All lies in jest till a man hears what he wants to hear and disregards the rest, right? When you're capturing four-way handshakes of your networks, it's harmless. When you're capturing four-way handshakes of what your neighbors transmitted, you can say, well, I'm sorry, Judge, but they broadcast it, so I'm not really stealing anything. When you start uploading the police department or the airport or the government's site, to this hashcat website, you're being silly, right? So don't do that. So be very careful. Pwnagotchi is like, it's a toy, it's a game. It can become very serious very quickly. All right. So what I'm going to do now this is a very contrived demonstration. It is not going to take long. because it's a contrived demonstration. If we got time afterwards, I'll run another real demonstration and show you. It's going to take time. Let me sanitize my file to make sure I'm not showing something I shouldn't be. I think I'm good. So now comes the part when you're all like, no, you use TeamViewer. It's convenient, guys. Whenever I do my pen testing class on Wi-Fi, I say inconvenience is a black hat's best friend, right? So inconvenience really makes life easy whenever you're doing any kind of pen testing. I think that's the one. There you go. Okay. So give me a second. I have to do some manipulation. When you successfully do an attack, it creates a pot file. So I've got to rename hashcat.pot file. Hashcat. Otherwise, hashcat starts up and goes, Dave, we've done this once and stops. Do I have a hashcat.pot file? Yes, I do. Hashcat.pot file. 99 or something, that'll do. All right. Now, I have a batch file where I have configured this to operate, right? Basically, I do hashcat 64, -m mode is 2500, which is a WPA2 attack, and A3 is fine-tuned hashcat, and I'm doing it with this file that I've already created. The SSID is called this, PSK1, and the password is called this. Now, this is a very contrived example. This is gonna take 6.5 minutes. It's gonna take 6 minutes to initialize my GPUs and then like 40 seconds to break this password. So don't go away thinking it's this easy, please. I want to make sure everyone understands that. All right, it begins. So here we go. Up here, I've got a little temperature gauge using open hardware monitor, monitoring my temperature. Now, this is a minor. The power's in the GPUs. I bought the cheapest CPU I possibly could for this motherboard, so we will get a little hang up when it starts, because the CPU is going to go to 100% utilization as it loads. Okay? Now you can see it down here. It's initializing the GPUs. It's already on device number 4, number 5. It's not going to do anything until it hits device number 8. Okay, I've got 8 GPUs installed. This demo is going to go horribly wrong in a minute because my screen will lock up, but it'll eventually come back. Here we go. I think it's because my CPU isn't powerful enough for the job, but I don't care about the CPU. It was like $40. The GPUs that I wanted to power. Right, now it's doing it. Now, if I press P for pause, oh, okay. It's been a bit slow. You can see the temperature of some of my GPUs have started to increase. Now I'm going to click S for status, and it shows me the status. Okay? I'm going to do S again. Let me do it again one more time. Right. I'm going to go up. It's paused. Now it's not doing anything. Let's look what's happening. Okay? It's doing hashcat. It's paused. It's using a PBKDF2. It's doing it on this. It's going through, and it's trying to calculate. Speed number 1, that's probably my 570. You can see it's 4 times the power of the 10 TIs. Okay. This one's having a good day. These two slightly more powerful TIs, they have secondary power plugged in. They're not the same model as all the others. Actually, this guy's doing fun as well. But you can see here, it's doing this many. It's doing 67 kilohashes per hour. So currently, I'm doing 211 kilohashes. Did I say per hour? Sorry, per second. Right? Now, scrolling down, you can see what it's doing. What it's doing is it's uploading different parts of the key space to the different graphics cards. Now, I'm going to press R for resume, and it'll start resuming. Now, I might not get any feedback now because I'm no longer paused. Oh, it's happy. It's doing its thing, all right? Happily chugging along. I can keep pressing S, and I can keep seeing it. Now, usually, once you see a capital C appear, it doesn't take long because Candy 123, it's like, oh, it's Candy 123. Now, you can see it's not responding to me now because the CPU is being too demanding. And you can see over here, look, you can see that the GPUs are getting a little warmer. Temperature's increasing. Now, it does have temperature protection, so if they get to, like, I forget the number, but if they get to an unsafe value, it stops or pauses. And by the way, Hashcat can resume. If I stop this now, I can resume it later, and Hashcat will remember where I got to. Here we go. Now, it's usually a lot faster than this. That's interesting. 224 kilohashes. Ah, okay. All right. So we can open for Q&A now. We just sit there and leave it run. And what will happen is it will get to it and it will come back and it will tell me what it thinks the password is, and we'll see that happen. So, Rod and Marco, if you wanted to open up for Q&A, we're just going to watch this do its thing now. And no, that's an S. I thought it was. Can you see? Look, done. Okay. Watch this. Hi, Phil. The SSID is PSK1 and the password is Candy123. Now, if you're all sat there gobsmacked with your jaws open, that was a very contrived example. Okay. Let me show you one more example before we open up for questions. What I'm doing now is, wrong one. So here's what I would run, which is 11.bat. This is like 101 days. I'm going to run 11h.bat, right? Now, what 11h is doing, it's giving Hashcat some inside information that the first character is uppercase, lowercase, lowercase, uppercase, lowercase, lowercase, 2 digits. This is the SSID. This is the password, okay? No, nothing fancy, just PESKAY05. So let's do 11H, and I will show you, okay, here. I think that's the end one, sorry. What it says, look at this here. I ran this, and it says we are 2 minutes, 55 seconds in, okay? It can take 203 days because it's doing the entire space, the entire 8. It's guessing, it's trying to guess based on 8 digits. Now, let me now run 11.bat. It will now redo. Now, there are some warnings coming up. I can optimize. I haven't really spent much time optimizing Hashcat. Hashcat's got a wealth of information. So I can optimize the operation. I can optimize how it searches. But I'll just leave this do its thing. And you can open for Q&A, please, gentlemen. And that's it. That demo was the last thing.
I believe there's a question. Is it possible for a client machine to act as the server needed for WPA2 Enterprise?
Okay. Let me look at the questions. I will answer that question. It's just about to start doing its thing. Oh, I seem to have lost my WebEx. Really? Can you guys hear me? Okay. My WebEx seems to have gone. And I can't stop sharing or start sharing. This happens to me now and again. Let me see. What's the meeting ID, please?
It should be under this page. Hold on. Try to,
Yeah, the way I fix it. Oh, hang on a second. No, it's gone. WebEx does this to me every now and again. The way I fix it is I go to my WebEx app and I re-enter the meeting number, and it lets me straight back in.
oh, I see. I can get you the.
If you're in WebEx, if you go into meeting and do drop down, it shows the meeting ID. I just need to type that number in, and WebEx recovers.
Oh.
I have a number there now, but if I click join, this may be the WebEx meeting I was on yesterday, and I don't want to get disconnected. Does it start 307?
It's 211-330-386. Spectre got it.
Hold on. So 211. Repeat again, please.
330-386.
Yeah. Now, this may disconnect my audio. We'll fix that in a minute. Okay, it's making me rejoin again, and I am back. Can you still hear me?
Yeah.
Oh, the magic of WebEx, because now it's telling me I've got to call in again. Brilliant. Okay. So if I quickly reshare my team viewer. There you go. So you can see it's doing its thing now. I'm going to pause it, and I'm now going to show the status. Now, if you look at this, right? I don't know what happened last time. Don't know why, but whatever. Now I'm getting 1,000 kilohashes per second. Okay. It's also telling me that it's okay. Interesting. Anyway, if I look up here, this is what I want to show you. It's telling me that it's going to take 8 hours. So the time estimated to search the entire search space is 8 hours. Now, where has it gotten that calculation from? Okay. Let me show you one more. I thought I had my calculator up. I'll just do this in my web page. All right. So because I said it's using uppercase and lowercase, and I told it it's uppercase, lowercase, lowercase, uppercase, lowercase, lowercase, that's effectively 26 to the power of 6. Okay. Then I said the last 2 digits are numeric. So it's that times 10 to the power of 2. Okay. Now, I just showed you that I'm doing 1,000 almost kilohashes per second. 1,000 and the kilohashes, which means that 1,000. And I just broke it. Fantastic. Divide by 1,000. Divide by 1,000 per second. Divide by 60. Divide by 60 is approximately 8 hours. That's where the numbers come from. Okay. Now I fed in uppercase, lowercase, lowercase, uppercase, lowercase, lowercase, number, and it's going to take 8 hours. What if I just let it do its thing and not tell it what it is? Well, that should be gotten by a calculation of 26 plus 26, uppercase, lowercase, 52, plus digits, 62. This doesn't include special characters. And that's going to take that long. That's a lot of numbers. Now, if I divide that by 1 million, which is my hashes per second, divide that by 60, divide that by 60, that's going to take 60,000 hours. Okay? And I haven't included special characters for that. Now, this is not going to give us an answer. If I Control C it and stop it, let me let you see as well. If I stop sharing, I know we've gone over time, and I apologize. We want to respect everybody's time, but hopefully everybody's having fun. If I now go back to my team viewer and I stop this, if I now run 11.bat, I'm not giving it any insight. Let's let it do its thing, and we'll now see how long this thinks it's going to take, and you should see like hundreds of days. Now, in the meantime, I did promise you I'd answer some questions, so let's do that. I'm going to stop sharing simply because I don't want you all looking at a grey screen, because that's boring. Now, I've lost, because I signed back in, Rod, I've lost all the questions, sorry. Could you read the questions out to me, please, Rod or Marco?
Sure. There's a question here. Where's the connection between reinforcement and the use of the brute force that you just used? So it sounds like your GPUs are doing a brute force attack with Hashcat.
Yes.
What was the reinforcement learning used?
It wasn't. So the AI on Pwnagotchi only makes it better at capturing four-way handshakes. There's no reinforcement learning or AI outside of Hashcat. Now, if you go to the Hashcat website, there's a lot of other options you can do, like the -A3. You can fine-tune that parameter. You can change the temperature limit of the graphics cards. You can, if you install the latest CUDA drivers and things, blah, 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 blah. I'm just doing it as a demo. I'm not really running this on that machine. So, because I would never do that, of course. So there is no reinforcement learning going on. I'm just doing a simple brute force attack, exactly what you said, with Hashcat. Yes.
Any other questions?
Were there some questions from before that I missed, Rod? Sorry.
There was one here. It says if it was possible for a client machine to act as the server needed for WPA 2 Enterprise.
Well, all you got to do is run a radius server. So what you've got is you've got the let me show you a quick. I apologize. You'd asked me that question. I said I'd come back to it. I will come back to that one. I just want to show you this screen. On this screen now, you can see that without me putting in the information about uppercase, lowercase, and numbers, it's saying it's going to take 71 days. Okay, it's estimating. And that's only for 8 characters. If it was 9 characters, it would be even longer. So let me show you one quick picture. And I've gone over time. I really apologize, everybody. Let me quickly bring up a slide. I didn't include this slide, and now I wish I had. All right. Okay, so this is the WPA2 enterprise concept. The supplicant, the client, connects to the authenticator, which is made up of the wireless LAN controller and the AP. Or if you're using a standalone AP, it'll just be the AP. Now, these connect to a Radius server. Now, what I'm saying here is no one puts users on Radius servers today. We link the Radius server to the LDAP, or we load the Radius server on the Microsoft Active Directory box. So the user database is now LDAP. But the Radius is the protocol that the authenticator talks to the database at the back end, the Radius server. Now, in answer to your question, can a client behave as this? If you're asking, can a client behave as an authenticator? Yes. Kali Linux, you can make it pretend to be an access point. If you're saying, can a client act as a Radius server? Yes. You just load the Radius software. So if you're on a Microsoft server, you load the Radius server. But it's a Microsoft server file. All right. If you're on Kali Linux and a client, you load freeradius.org. If you load a Radius application, it will act as the Radius server. And freeradius.org is one of the simplest ones you can use to do this. It's free Radius server. So can a client act as the server? Well, yes, absolutely. Does that answer the question? Can you guys hear me?
Yeah. It seems like no more questions for now. This was an incredible talk. Phil, this was a very, very, very good talk. Thank you very much for
Thank you, sir. Thank you.
for giving us such an in-depth. You're more than welcome to present another topic anytime you want. This was incredible.
Well, maybe we should look at that 30-minute slot I did in the hacking where I talked about WPA3.
Yeah, I think
I also talked in that about what was wrong with WPA2. So if you want to open up a slot later in the year, we can talk about what's wrong with WPA2 and why WPA3 will fix it. So if you want to, maybe later on.
Yeah, we can do it. Maybe we can do it on since we're still not going back, and then there's not going to be DEF CON, and usually that month we have the preparation talk. Maybe we can do it in July or August. It depends. We'll refine the details soon. But this was incredible. Any final words of how you, besides coming up with very complex passwords, any other ways to protect against this? Like, for example, I noticed that my APs were being attacked. I had netgears, and this netgear, they, for some reason, I started seeing my devices being falling off the network, and then I would see a lot of my APs like crashing, basically losing the internet connection. Is there any open source tool that will detect that somebody's poking around or being aggressive against your APs?
So first of all, there's nothing you can do about it. You can't stop it. Not with WPA2. What you need is some kind of wireless IDS. Now, they aren't cheap, and there's no free ones out there. So I do a lot of work with Cisco. So what I do on my wireless hacking classes, my wireless security classes, is I do an M-on-NG deauthentication attack against my client on my network. And I do it again, and I do it again. And they say, okay, so Mr. Black Hat is very happy now because he's causing congestion. Then I go to my Cisco wireless LAN controller, and I turn on the security option, and I say, have we seen anything? And it goes, yeah, I just saw 3 deauthentication attacks on your network. But I can't locate them, Rod. I don't know where they came from. I can just detect them.
Right.
I don't know where they came from. Now, the equipment, the hardware and the software to give you location specifics of where they came from, we're talking tens of thousands of dollars.
Right,
so
right.
There's no easy tool because you'd think someone would write one, right?
Right.
Yeah.
Right.
So
Well,
you've got like...
I figured if you're in an apartment, for example, you could possibly use Kismet and then grab a inventory of MAC addresses and see if those MAC addresses have been in your AP, and that will be like a forensic way of seeing where the attack is coming from. But even then,
actually, if you use old Kismet, which was text-based, or if you use new Kismet, which is GUI-based, they will pick up deauthentication attacks. There's also another application called Host, which, so I tried to get Kismet working on a Raspberry Pi 4 or 3, and apt-get installed onto my Kali Linux, and it went for about 20 minutes and said, sorry, I've run out of room. There's no RAM left. This is Raspberry Pi 3, I'm sorry, not a 4. There's no RAM left to download the software, okay? So I know some people who've messed around with something called the Wireless LAN Pi, and I'm like, how do you guys get Kismet to work? They're like, oh, we compiled. Okay, yeah. They downloaded and compiled locally. So I wanted to get a nice, easy system. Host can give you some feedback. The problem is Raspberry Pi won't run Kismet. Now, I didn't try it on a Raspberry Pi 4. If you've got an old laptop or something lying around, you could technically load Kismet on the laptop on like Kali Linux and then have it running, and it will warn you if it sees deauthentication attacks, if it sees maybe, actually I don't know a list of all the attacks it sees, but it will detect deauth attacks. So that could be a start. Right.
That's the closest we can get to detect anything like this.
Yes, but you know, you've now got to have a dedicated machine running at home. There's nothing you can load on a laptop that you're using, for example. You could use Wireshark, but you have to leave Wireshark on constantly. So the only thing you could do, and maybe I haven't played enough with it yet, maybe we could get Kali Linux and Kismet running on a Raspberry Pi 4, which might be enough. That's like $50 machine, maybe.
Well, that's an idea. I mean, because nobody seemed to have done this before, and I figure when I was having these attacks, it's a pain in the ass because then you had to restore your APs. You don't know if you know how deep the attacker had gone in. It basically forces you to change a bunch of stuff, and I had no way of knowing it. I would only know when the AP crashed, and then if you have an extended Wi-Fi, then it's even more difficult. because you truly can tell where the attacker is located. So that's why I was asking.
So a couple of few comments that are very important, and please, I know we're over time, but please hold on for these. Number one, if someone's de-authing you, it could be the script kiddie next door that just watched a video on it, Rod. Yeah?
Right.
Because it's easy to do. You download Linux and it's like one command. If your APs are crashing, that's a little bit more serious because people are now doing denial of service attacks against your APs, causing them to crash. So the way I explain to people is, look, this is real simple, right? Walmart has 200 car park spaces. If the car park is full, you can't shop at Walmart. Access Point have slots. If you fill up the slots, nobody else can connect.
Right.
So there's loads that you can do. I can send lots of authentications. I can send lots of SSID broadcasts. I can cause your APs and your clients to get confused. There's loads of attacks you can do against Wi-Fi. But when your APs are crashing, that's a serious set of attacks. Now, this is very important in the current climate, Rod, right? Because we're all working from home. We have a Cisco next generation firewall with a Cisco IDS with another, I've forgotten the name of the company that make another firewall. Never mind. We have another vendor's firewall because we're smart enough to have firewalls in depth at the office. At my house, we've got a Netgear or a Linksys access point. Now at my house, I have a Cisco firewall protected my network, not my family network, but my network, right? The point is, now that we're all working from home, how much money did your boss spend, Bob, on your home network? Oh yeah, he let me buy a more expensive home router from a local retail store for $300. Did he upgrade your malware engine? Did he upgrade your antivirus engine? Did he give you a host IDS functionality? Nope. So all the black hats are out there rubbing their hands together, Rod, because they aren't going to get past our company next generation firewall anymore. They're just going to get in our whatever home router, right?
Well, I did figure out that once I changed my APs I installed the latest latest Google Wi-Fi. The attacks seem to have stopped. I didn't have any issues anymore. I tested them myself, and I couldn't do anything with the Netgears. I could. I was using a lot of some of those tools that you shown. Mm-hmm.
Yep. So I think I mentioned it in the conversation somewhere. The newer APs, even the home APs, are becoming more resilient to some of the more common attacks. Now, denial of service is still nothing we can do about it. So we can't stop people attacking us, but we can let our infrastructure become a little bit more resistant to it. Now, as somebody mentioned, the only way we're going to stop DOS attacks is 802.11w on the infrastructure and the clients. WPA3 is going to give us more protection. So our Wi-Fi world is going to become safer any day now, Rod.
Well,
just not today.
Yeah, I'm looking at this. I'm going to share this because this is interesting. Before we close up the meeting, somebody just shared a very interesting project. I'm going to show it now. This is apparently a Wi-Fi IDS made home. That's awesome. Thank you, whoever posted this. And as you can see here, is based on alphas. This is pretty cool. Can you see this, Phil?
Yeah. So I don't want to be the killjoy, but it's based on alphas, right?
You don't like alphas?
Well, it doesn't do 802.11n, it doesn't do 802.11ac, it doesn't do 802.11ax.
Oh.
So please, whoever's doing this, please carry on doing it. Somebody else did this a couple of years ago, Rod. They had an idea. We want to build a wireless IDS, a free wireless IDS. And that was the last I heard of it. So what is this called? Oh, this looks good. You see, the thing is, second thing, if you go down, you scroll down, now those are platinum alphas, so they should do 5 gigahertz as well. But look at the others.
Oh,
you use the 36s and the pandas, you're safe on 2.4 gigahertz, but my opinion, we shouldn't be using 2.4 gigahertz anyway. 5 gig is the way to go. Well, 6 gig is the way to go as of 2 weeks ago. But this is better than nothing.
Right.
But is this going to be better than Kismet? Is the question, right?
This is really cool.
It's a start, and it's better than nothing.
Right.
And I hope they keep working on it.
Yeah, this looks pretty good. Thank you, whoever posted this.
Yeah, awesome.
Any other?
I think there was another question before that.
You want to read it? You want to go ahead and read it?
What do you think of this as an idea for protecting a home Wi-Fi network with us? I think they were referring to, just to reduce the number of slots for the access point to one slot.
Yeah, no. Because all I got to do is fill up the one slot, then you can't get on.
Right. Oh, also there are some access points that they had registered the max, and we all know that it doesn't work for airplanes.
Well, I had an argument with a guy in the class who was defending MAC address filtering, and I'm like, dude, that takes me 20 seconds to bypass. And in the end, we had to agree that, okay, if you want to turn it on your network, you go, you knock yourself out. But, MAC address filtering and hiding the SSID do not stop a black hat. It does not stop my grandma getting in your network, guys. Go.
See, there's another comment from Samuel.
Now that's a good point. If you have older APs that don't have some of the advanced security, by going to OpenWRT or DDWRT, they may give you more protection. But I've got to warn you, you only use OpenWRT and you only use DDWRT if the access point you're going to do it on, you are prepared to brick. You can brick an access point doing this.
Actually, I just did.
You just did?
Yeah. I actually get it back, but it was brick. I bricked 2 already. Not this time, but I did break a older router that I was playing with DDWRT, and but I learned from my mistake. So now this time, actually, it was almost break, but I was able to recover. And I'm just talking in the last 5 minutes or so. So it was good.
Yeah, that's awesome.
This has been an amazing presentation, and even more now with what you just said, that we are all working at home. And again, I have to say it, when I started working at home, this was like a month or so, I started noticing that my APs were going down in suspicious hours, by the way. It looks like they were waiting for me to go to bed.
Yeah. So, absolutely, yeah. One of the biggest things about home working, to everyone to be aware of, is when you use a VPN working from home, okay, all your traffic is encrypted, right? But you still have your ports open on your laptop. People think that all traffic goes through the VPN. But if I ping you on port 23, if you got an application running on port 23, you'll respond. So make sure you've got your firewall turned on Windows, on Apple. Make sure your firewall's turned on, everybody, and run like Malwarebytes and an antivirus application. Because the hackers are now turning their attention to us at home, and they're easy picking. I say hackers using the media. I know that hackers have the word crackers, so please forgive me. Let's just call them black hats, yeah?
Right.
And the Wi-Fi is easy pickings, right?
Any other questions?
Just quick question, but I don't know if that's is like reducing the antenna, the power on the antenna. Does that help? I mean, to a point. I know it's not gonna completely, solve the problem, but does it work? I guess from your experience.
So when you reduce the power on your AP, or you change the antenna, you will change the coverage area of the AP, which means it doesn't leak out as far as it did before. But please remember, when I increase the antenna on my AP, I can still hear you. So you never decrease the power for security purposes. You decrease the power. Well, let me stop there. You decrease the power to get the coverage you want in your house, which technically is doing it for security purposes. But you don't turn the power down to the minimum so that it doesn't leak out the doors, because then you won't get a signal upstairs. Okay? So you can manipulate the power for cell coverage. Now, that may have a little bit of overlap with security, because if you can pick up the signal 80 feet away from your house, maybe you should turn down the power. Absolutely. But remember, if I'm sitting 4 doors away from you and I change my power, it's going to have no effect on how I hear you. But very quickly, this is my wand of power. Look at it. Leviosa. It's an alpha antenna. If I plug this into my, I've actually got video on. Can you see my video? I tried to get my.
Actually, I'm going to stop sharing so you can share. Go ahead and share now.
So I wasn't sharing. I was trying to put video on.
Okay, you should be able to come up now.
Okay, I can see my video, but I can't see it on my iPad. Okay, I have a. Can you see me?
Yeah.
Awesome. Yeah, so you can see my antenna. So by having a longer antenna, I'm changing the focus of my signal, but I'm also increasing how I hear you. So if I have a 6 decibel antenna, that effectively adds 6 decibels. Basic maths without going too in depth. If I add 6 decibels of energy to my RF, I double my coverage area. Okay, so very, very quickly, without too much maths involved, a quick statement. If I add 6 decibels of signal, if I change my antenna from a 3 decibel antenna to a 9 decibel antenna, I hear you 4 times as strong. So I double effect, very, very basic. There's a lot of argument and math to go in with this. Basically, I can hear you twice as far away. Is a very basic statement that I need to think about a lot more. But if your signal goes to the edge of your building, 80 feet away from your access point, and again, guys, please don't email me about the maths. I'm making this up on the spot. If I change my antenna from 3 decibels to 9 dBi, I can now hear your signal 160 feet away from your AP in the car park of the grocery store next to your building. Now that's what no one tells you about Wi-Fi. Okay, so please don't write in about complaining about my maths there. That was me making it up on the spot. And by increasing my antenna's dBi value, I can hear you better.
There is one more question. Does 802.11w prevent denial of service attacks?
That's what it's meant for, yes. But only to those clients and APs that support it and have it turned on. So what 802.11w does, it creates another MIC value, which is another CRC type thing. Okay? And what happens is it doesn't stop de-authentication attacks. It stops de-authentication attacks working. So I can still do a de-authentication attack against you, and your client will be like, I just got a de-authentication message from my AP. He didn't include the magic password. I'm ignoring it. And so your clients will not be de-authenticated. So de-authentication doesn't work anymore when 802.11w is working properly. That's the idea. That's the goal. But here we are in May 2020, and not all clients and vendors have proven that that's working. Got to have 802.11w. You got on the turned on the AP and supported on the client. That's the problem, right?
Right. We're gonna close up with this last question. If I hide my SSID, is it a good solution for this kind of problem?
No. Hiding your SSID doesn't hide your SSID. Hiding your SSID stops the SSID being advertised in beacons. Hide SSID, the beacons still go out, but they go out with a null value. And Susie turns up for work tomorrow morning and says, are you there, Top Secret Network? And all the APs that are configured say, yes, we are here. Welcome to Top Secret Network. And Susie says, can I associate to Top Secret Network? And the APs say, yes, welcome to Top Secret Network. I do a demo in my class where I turn on AeroDump NG, and I colorize the line, and we sit there and wait, and then I log in on my hidden SSID with my client, and AeroDump NG goes, oh, there you go, I'm associating. I've just seen the advertisement in the association frames that maps to the BSSID in the beacon that's hidden. Here it is, seconds, and not secure. See, there's a school of thought now, right? If you're hiding the SSID, why are you hiding it? What you got to hide? Now I'm interested, right? So you've made yourself a bigger target by hiding the SSID. Because now people are like, oh, what have you got to hide then? It's just my theory on it, that's all.
All right. And with this, we're going to close up. We have a upcoming meeting on May the 23rd, which will be for container security and drone security. Thank you very much, all of you. And I'd like to thank Phil again. This was an incredible presentation. I will be saving it and posting it in the YouTube channel for everybody to watch. And again, please join us at the Slack. And I'll thank you very much for your participation, and stay safe out there. Thank you very much.
Thank you, Phil. Thank you so much,
guys.
for your presentation.
Thanks, Rod.
Thank you.
Stay safe, gangs.